If you push a block, but it doesn't move, you did zero work. In physics, work is defined as the transfer of energy when an object is acted upon by a force and it's displaced, else work is not done. Formula for work is force into displacement into cos theta. Theta is the angle between force and displacement. Theta should never be 90 as cos 90 is 0. So, force and displacement can't be perpendicular if work is being done. If the force changes every second, then you must integrate it with the formula shown. Because integration adds every work being done every second, which can't be done by the simpler formula. The area under the curve of a force versus displacement graph gives work. Now, in this simple example, you just have to apply the formula work equals force times displacement. Always write the given information first as it eliminates confusion. Once that is done, think of what formula to apply and then substitute the values to get the answer. In this one, angle is given, so write the given information first, then apply the formula. You must apply work equals force times displacement into cos theta. Be careful with the value of cos theta. In this next one, the force is variable. Now you must integrate it simply with putting the limits according to the position vectors. The coordinates of final position becomes the upper limit and the initial position is the lower limit. Integrate both x and y components of force and add the final answer. You can try this graph question and drop the answer in comments. Find the area and subtract the one below the x-axis from the area above the x-axis. Next, work done by common forces. Gravity's work done is mgh, as demonstrated. It does positive work only if displacement is downwards. Normal force, it does zero work in most cases as it's perpendicular to displacement. Spring force, it is kx, so we must integrate it, which gives us the formula as shown. Finally, friction, it applies in the direction opposite to motion, which makes cos negative as theta equals 180. Next is the work energy theorem. It simply states that the total work done on a body is equal to change in kinetic energy of that body. Here's an example where we apply the theorem to find final velocity. Simply calculate the total work done of all forces being applied and set it equal to final minus initial kinetic energy.